where we stopped. Are you getting it? Let's continue from where we stopped. Now we have talked about integer data type, isn't it? We also talked about boolean. We talked about string also. Are you getting it? So let's move on to another data type, another useful data type. Are you getting it? So let's talk about enums. Enums. So up until now, let me get a new file. File, not a folder. File. Enums. Enum dot sort. Let me just copy paste. No, not this. How am I doing? Not here. Delete. Enum dot sort. So let me copy paste this part so that we don't have to write it again from scratch. I will rename my contract to be enum data type. Now, up until now, all the types that we have been working with are called the basic data types or the primitive data types. So the types we have been working with so far are primitive data types, or you can call them basic data types. So these are the types that we have been working with since the beginning of the bootcamp. Now, why are we calling them primitive data types? Because they are simple data types. They are kind of, let me just say, they are data types that are predefined in the Solidity language. Are you getting it? They are predefined in the language. That means there's a definition for them already. Are you getting it? So when we say a data type in the first place, it simply means a variable and the set of values that that variable can accept. That's what I mean by data type in the first place. For instance, we talked about the int data type, have we? So we talk about int 32 and so on and so forth. So why are we calling it int 32 data type? We are calling it int 32 because it is a data type that can accept a set of values. And what are the set of values that int 32 can accept? Integers 1, 2, 3, 4, 5, 6. So when we say data type in programming, we are talking about the set of values that a variable can accept. Are you getting it? Or the set of values that can be assigned to a variable. That's basically what data type is. So the same thing, when we're talking about string, we did something like this, string public, and we did greeting like this. So this data type string also is also telling us the type of data or the set of all the values that this variable string greeting here can accept. So if I put something like this, if I assign something like this to the string, hello, it is correct because it is part of the values that it can accept. If I do just word, or even if I do hello word together, you know, it is also what acceptable. So these ones they are called primitive data types. Do you understand? Now when we now talk about user-defined data types, example is enum. Example is There are sometimes whereby you need your own data type. Are you getting it? So let me show you how to create one. So how do you create enums? So to create enum using the enum keyword like this way. So enum, then give it a name. You give the enum a name. So let's say you are working on, let's say, a food delivery application like Glovo or Chowdeck. Are you getting it? Or any of those food delivery applications. Now, when a user make an order or orders for a food, at first the status of that particular user or that particular order is going to be pending. It's going to be pending. Are you getting it? At first. Now, as soon as the delivery guy or the delivery person delivers the order to the user or to the customer, the status becomes what? Let's say delivered. You change the status to what? Delivered. Now, how do you represent this kind of things in programming, in Solidity in particular, as in our case? So one thing you can do is to do something like this. You could do something like this. You could do string public, then you do status one like this. Then maybe you give it pending this way. Then you come here, you do string public status two, typo here, status two, and maybe give it, let's say, delivered here like this. Now, if you create something like this, that means if you have more than one status, that means if you have like 5 status, you have to keep, you know, creating another name. Let's say I have another one, string, let's say public status 3. Let me call this one here paid. So if I make this one here paid like this, let's say I have another one, string public. Let's say this a user decided to cancel his or her own order. So if I have status like this and I make it, let's say 4, I can do, oh, oh, sorry. Why is this thing behaving like this? I don't know. For some reasons, I don't know why this thing is. Okay, everything is back. Sorry. I don't know what's wrong with my browser. Let's go back to the contract folder and enum. So we still have our file. So back to, so let's say a user decides to cancel his own order. So you can come here and do something like this. Cancelled. Cancelled this way. So you will not be wrong if you do something like this. Then let's say in places where you want to check for the status, you can do if, let's say you want to print the status. That means you have to check the user's status and do, let's say, if user, let me do something like this. Let's say user status equals to any of these. Let's say status one. Then you do anything you want to do. Same thing for status 2, status 4, and 3, and 4, and so on and so forth. Are you getting it? Now, this will not be wrong if you do it. It will not be wrong if you do it this way. But then this is more verbose. Verbose in the sense that you are typing a lot of things. Are you getting it? And also you can lose track of all the status that you have in your application. Are you getting it? You can lose track of all the status that you have in this program. Yeah, you're having 1 to 4. Imagine you have like 10. Are you getting it? That means you have to keep track of everything. Another thing is naming. One of the challenges in programming sometimes is naming things. That means you have to, if you are keeping track of like 10 statuses, that means you have to keep track of the names of those 10 status in your smart contract. So what is the better way to go about it, or what's the nicer approach or the better approach to go about it? And that's where enums comes in. So how do you write enums? You write enum like this, which is a user defined data type. That means you are the one defining it. It is not defined. It is not primitive. It is not predefined for you. So you do status like this, then you open your braces like this. So after opening your braces, you put in all your status one by one: pending, delivered, paid, cancelled. Now, as you might have noticed, you can see that this one here looks more clean than this one here. This one here looks more clean, looks cleaner than this one here, because you're having just one variable. You're tracking all the statuses with just one variable. Unlike this one here, where you are tracking with everything with different variables, 1, 2, 3, and 4, and so on and so forth. Are you getting it? So that's the benefit of using this one. And also, mind you, when writing your enum, anything you're writing between these curly brace should not be in quotes. Are you getting it? So you are not writing a string. What you're writing is not a string. You write it like this. Are you getting it? So let's try and print out. Okay, let's try and declare a variable. Let's declare a variable. So here now, if I want to declare a variable based on this data type, remember I told you about integer, string, and other data types like Boolean, that they are primitive. That means they are predefined in the compiler. Are you getting, or in the language? So if I want to declare an integer now, I'll do int 32 like this. I'll give it a public. I'll make it public. If I want to declare age, I'll make it what? 32. Are you getting it? So this integer 32 here has been defined somewhere in your Solidity, but you don't have access to it. Are you getting it? That's why it is called primitive. But this one here now, this enum here now, you have access to it. You are the one defining it by yourself. Are you getting it? So to create a variable out of it is very simple. So you just come here and do status. Now this status here must match the name of the enum. So because this enum here is status like this, you have to make your variable to also be status like this. So you give it a name, or you make it public or private. So let's make it public, as we have been doing for others. So you give it a name. Let's say ongoing or pending. Let's call it pending. Pending like this. But let me just call it ordinary status. Or other status. So after doing this, you come to this place and you type status like this status. Then to access any of these ones there, any of these pending, delivered, paid, or cancelled, use the dot operator like this. So it's going to, the Solidity compiler, or the IDE rather, is going to show you, is going to give you auto completion. So you can pick any one of them, or you can manually type it out. Let me manually type everything out. So I'm having pending this way. Then I terminate with what? Semicolon. Are you getting it? So this one here now is one way of using enum. So instead of you having to write, rather than you having to write um, pending status one, um, deliver status two, and so on and so forth. You write everything at once, then you create a variable out of it. Are you getting it? So that's the use case for status for enum rather. Now let's deploy this smart contract and see what it's going to give us. Let's deploy it. So this age, let me comment out this age and this one here, and leave just cut this one here and put it somewhere here. So let me just deploy this smart contract. So it is compiled now. Let's deploy it and run it. Deploy. So it is deployed now. Let's see. Let's see what it gives us. It gives us rather. So if you check the greeting, this is the greeting here. We should be seeing word there. So as you can see, there's word here. Now for the other status, because we are picking status.pending, let's see what it's going to give us. So as you can see, we're having what? We're having 0. Are you getting it? So that brings us to another thing about enums. When you are writing enums, the order of which you specify your enum variables or values rather is from 0 upward. Are you getting it? So this pending here stands for 0. This delivered here stands for 1. This one here stands for 2. And this one here for 3. And so on and so forth. Are you getting it? That's why enums are. Now you can decide to make your own start from 1. Oh, it doesn't work here. Let me see. I think Solidity doesn't have that feature. Okay. Just start from 0. So let's pick another one. Let's do delivered this way. Let's recompile. If we compile it, go to the deploy. Let's delete this one here. Deploy. So check our other status this time around. We should have 1. So it is 1 like this. Are you getting it? So that's that about enums. So enums are custom data types or user-defined data types in the sense that you are the one defining them. Nobody is not coming. It's not the follow come data type. The user-defined data type. So that's that about that. Now let's talk about another data type. Let's talk about the structs. Struct data type. Coming. So the next one is struct. So how do you define structs? Use the struct keyword like this. Struct keyword. Then we give it, let's say, a name. Let's say person like this. Then okay, let me give it uint 32. Let me give it string of name like this. Uint 32 like this. Oh, uint age rather, not 32. So let me give it age and name. Now you may be wondering, why do we need a struct? Why do we need a struct? So let's explain the reason why we need a struct. Let me comment this one here out. At the top of this, you should have a comment. Struct or structure. Now, it's actually called struct. I getting, but as you might have guessed, the full meaning is structure. I getting, or the full pronunciation is called structure. So why is it structure? So it's structure because it helps us to, as the name implies, structure our, our variables. Are you getting it? Say you are building an application now, and you want to manage the user's name and the user's age and other information about the user. One way of going about it is to do something like this. Let's say for the user's age, you can come here like this, int32, declare a public variable and call it age like this. Let's say the user is 10 years old. Now you now want to manage the person's name. String public this way, name. Let's say the person's name is John Doe. John Doe like this. Say you want to manage another thing again about the person. Say, okay, the person's city. Person lives in Lagos. Say you want to manage, let's say, you want to check if the person is a programmer or not. So let's do Boolean or bool public is programmer this way. Let's say the person is a programmer, so we use true like this. So as you can see, we are using all these variables here to manage everything about one user. But then all the variables are kind of scattered. They are not grouped together. So that's the work of a struct. So what the struct does is to help you group your variables together, to help you merge them together so that it will be easy for you to manage them and for you to track them and for you to know which one is for which one. For instance, I may not know that I may not even know at first glance what this age, name, city, and this programmer is. If I'm to look at this code, if I'm not the one writing the code and I come here, I may not know at a glance what this line of code is doing. But if I should come to this place now and I see this struct person here, this person struct rather, I can easily deduce that, oh, I'm seeing struct person, then definitely this thing here is, symbolizing a user data. Are you getting it? So that's it. So that's the reason why we use structs. So let me first of all, let me comment this one here out and print and show you all these ones here when we deploy it. Let's deploy it and see. So if I compile it, what is it? Hello.
Hi Toby, please can I say something? Sorry to
Okay.
disturb.
Okay.
Yeah, please the attendant. Okay, yeah, the link for the attendance has been sent to the call chat. Please, you can fill it, and as you join, you fill it. Thank you.
The attendance.
Yes, like for the participants.
Okay.
Yes, thank you.
You're welcome.
Please, you can continue. I'm done.
Okay. I'm almost done filling it.
Okay.
So where were we?
About to deploy.
Yeah, we're about to deploy. Thank you. So let's compile it. I've compiled it. Now to deploy, we come to this place, delete this one here, and deploy. So from here we can see all our variables. Our age is 10, as stated there, or as written here, or as coded here. Our city is Lagos. I'm still greeting the world. John is a programmer. John Doe is a programmer. So we have this. Are you getting it? So this is one way of doing it. So a better way or another approach is to use structs, which I just finished explaining. So to use structs, you do it this way. Are you getting it? Now, just like structs is a user-defined data type. Are you getting it? It means you are the one creating the data type by yourself. It is not primitive. The data type is not primitive. Unlike uint here and string here. For you to use uint and string, you have to do what? Define it by yourself. So you have to just use it directly without defining it by yourself. But for you to use structs and enum, you have to do what? Define it. So I've showed you how to define enum. The next one is how to define the structs. Are you getting it? So let's continue. So this one here, we don't need this one here for now. So to now create a variable out of this, it's going to be person like this. Person, public person. Person, then person like this. So this one here now is going to accept two arguments. We type your person data type. This person data type here corresponds to this person here, just like we had struct here. If you check, let me get rid of this one here. Sorry, not struct here. I mean enum. When we define the enum data type, we have status here. Are you getting it? When we wanted to create a variable out of this, we started with what? Status here. So the same thing happens here. Defining this struct data type, we have person here. To now create a variable out of it, we also need person here. Are you getting it? So that's it. So the person here is showing that we are dealing with the person struct data type. This public here shows that it is publicly visible. Why this person here is the main variable name. So how do you create a struct? You type in person like this, open your parenthesis and close it. Then you terminate with semicolon. Then inside this person here, you type in the values of these variables that you declared inside it. So inside here, I'm having age and name. Are you getting it? So I can do, let's say the person's age is 32, like this, and the person's name is, let's say, um, let me still go with John Doe, like this. So with this, we have created a variable out of this data type here that we declared here. So it's as simple as that. So you type in the words, the struct's name, public. Is similar to all we have been doing here. Are you getting it? But the only difference is that for us to use this person, we have to first of all define rather how the struct is going to be, and that's what makes it a user-defined data type. Unlike this one here, where we don't have to do anything. String, boolean, integer are not user-defined. They are primitive. You don't have to define it. You just use them. But this one here, this person here, is not known by the compiler. You have to define it by yourself for yourself. Are you getting it? Before using it. So that's why we have to do something like this. And to define the struct, you start with the what? Struct keyword like this. The name of the name which you want to give to the struct, which can be anything of your choice. Then you define your variables inside of it. Do you understand? So that's it. Now let's deploy it and see. Let's deploy and see. If I should come to this place and compile it, it is compiled. Now to run it, click on deploy and expand this. So on click of this person here, we can see that the age of this person is 32, as stated here. And also the name of this person is John Doe, as we have written it here. Are you getting it? So this is how you declare the struct data type. Any questions so far? Everybody? Hello? Hello, everyone.
Hello.
Any questions so far?
No, no question.
Hmm?
No question. No question.
Okay. In the absence of none, let me quickly give you a class work, a simple class work. I want you to create an enum for me. Submit it um, in the chat, Google Meet in call message. Submit it here. So create an enum for me that uh, create an enum for gender. Gender. Create an enum for user gender. So I'm expecting your answer before 8:34. Before 8:34. This is 8:32 or 33 rather. So create an enum for user gender. So think of all the types of gender we have, then create an enum out of it. Are you guys with me? Hello? Hello?
I will submit it in the call.
Yes, in the in-call message.
Okay.
Yes. Are you guys on? Okay. Chinedu, I can see you on. This is good. Which one is QI again? What gender is that one? Yeah, this is good, Sha.
It's like you said all the gender we could take.
Yes. Which one is QI again? Okay. What is
I
it?
don't know. I just used to hear it.
Hello? It's okay, it's okay.
I don't know. I just used to hear it. Sha.
Okay, you used to hear it. Okay, okay. Check it. Maybe after the class. So male, female, gender. Okay, that's good. Lakon, that's also good. Now, having done that, let's do another one. Okay, I want you to create a struct for, let's say, a car. You know a car. You know a car. Okay, let me say a vehicle. Let me not call it car. Let me call it vehicle. Like this. You know all the properties of a vehicle. The number of wheels, then number of seats, like this. Then the color, then um the model number, then number of wheels, number of seats, color, model number, uh, year of manufacture. So I want to create a struct for this. Should be a vehicle. I get it should have these properties there. Number of views, number of states, color, model number, and the year of manufacture. Are you guys with me? Hello. Okay, Chinedu, I can see your own. Okay, number of views, number of seats, year of manufacture, model number, numbers, manufacturer's number. Okay. Well, syntactically, there's an error in your work, Chinedu. Let me just copy it and paste it on Remix so that we can see it. So if I paste this code here now, what do you see? Let me format it so that we can see. First of all, you're having comma here. You're supposed to terminate with semicolon, not with comma. Do you understand? And the next thing is that this number of wheel here is not a phrase, even though it is, even though it sounds like a phrase. Are you getting? You don't write it like a phrase. You don't write it like a sentence. Remember the rule of identifier when we first started, that an identifier cannot have special character. Now a space, this space here is a special character. This one here too is a special character. If I should come here and I put hyphen here, this is also a special character in programming and in Solidity. Do you understand? So you should not put a space in your variable name. Think of this number of wheels here as your variable. It's the same thing. In fact, this number of views is the same thing. Now, if you observe, if you watch my own, when I was playing this programmer here, I could have done something like this. Is programmer. But if I do something like this, I'll be wrong. Are you getting it? Because the rule of identifier says that there should be no space between a two-word variable. Are you getting it? So that's why I decided to write it this way. So this way of writing it is called camel case. Camel case simply means that the first word will start with small letter, then the subsequent words is going to start with what? Capital letter. Are you getting it? That's what we call camel casing. Do you understand? So the correct way of writing this will be number of like this, then views like this. And that's why I wrote mine this way. Do you understand, Chinedu? Hello, Chinedu. Okay.
Understand it now. Understand it
Good.
now.
So the same thing for this one here. Now, if you don't want to write it this way, in this camel case way, you can also use what's called snake case, where you use underscore of. Remember, I told you that you can't use special characters in a variable name, but then there's an exception. The exception is underscore. So if you use underscore, it's not going to yell at you. Are you getting it? Just like it is not yelling at me here. Do you understand? But then another thing is that if you are using underscore, use underscore or true. If you are using this case here, this camel case here, use it all true. Just be consistent with the way you write it. Sure you get. So one of the ways of writing, one of the good ways of writing program is consistency. If you are using camel case in your program, use it all true. If you are using snake case, use it untrue. Don't start mixing everything. If you mix it, well, your program is still going to run, but then it can be hard for people to read. Even yourself, you may find it difficult to read it at some data points. in time. Sure, you get. So another way of doing it is this way here, number of seats. Then you have your colon here, your colon here, and your colon here. Do you understand? So the next thing, let me change this one here back. Remember, you have to be consistent. Number of seats this way. Then year of manufacture. Year of manufacture. So this one here is going to be model number and a manufacturer's number, like this. So another thing is, if you check this one here, you wrote everything in lowercase. You wrote everything in lowercase here. For this ones there, you started this ones there with uppercase, capital letter. So this UNs and this string here, they are keywords. Keywords are usually case sensitive. So what we mean by case sensitive is that if you're having UNs like this, you can't come here and write UNs like this. These two things are different. They are entirely different in programming. Are you getting it? So it will be wrong for you to have these two. For you to write this one here in place of this one here. So if you're writing any keyword, you write it as it is stated by Solidity. The way Solidity wants you to write it, that's how you write it. Do you understand? So in this case, Solidity wants us to use what? Lowercase. So let's turn this one here, this capital letter U to small letter U. Then let's make it, 8 like this. Do you understand? So that's it. Now the next one, which is the last one, is this string here. So the string is also supposed to be in small letter. Abi now? Yes, now. So it's supposed to be in small letter. Another thing is the structs. The structs is also supposed to be in small letter too. Not here. Let me bring it down. So yeah. So as you can see, all the errors are now gone. So congratulations, Chindu, you have successfully created your struct. So let's check Lacon's zone. Okay, that's good. But then this way of, let me copy your own too and paste it. Copy, paste. So this is, let me see. Okay, you made a mistake. It's supposed to be uint, not unit. Okay, you typed unit here. Are you following Lacon? So it is uint. That's programming for you. The compiler does not. Compiler is not going to guess for you. It's not going to guess for you. If you type anything wrong, it's going to yell at you. Unlike we humans, that now you make it. I can tell this is what trying to write, or this what this is trying to say. But then the compiler is a mindless program. It does not have a mind. It cannot think the way we think. So you have to be precise with whatever you are typing or writing. Okay, you get. So I think you also have another error somewhere else. From where? Okay. The reason why we're having another error is because we have this vehicle here. We declared one vehicle here, and we're declaring another one here. So let me make this one here vehicles, and the error will become. Now, another thing about this one here is that this is Pascal case. There's nothing wrong with naming your normal variables this way. Are you getting it? But then this casing here is called Pascal casing. This one I wrote here is called Camel casing. The difference is that the first word for this one here is small letter. Every other subsequent word starts with capital letter. But for this one here, all the words, all the beginning letter of each word rather starts with capital letter. Are you getting it? That's the difference between this and this. Now there are places where we use this and there are places where you use this. If you use any of them interchangeably, it's still going to work. It's not going to give any error. Are you getting it? Because the compiler will accept everything. But then for readability purpose and to follow best practices, that's how other people write, how most people write. Use camel case for your normal variable. So this one here, you can use small letter here to make it camel case. And small letter here too. Then the color, this. Then the model number should be this. Do you understand? So that's it. So sorry, it's my network. Let me share my screen again. So that's about that. Now let's move on. Another thing is array. Let's talk about array. Let me comment this one here out. Array. Now when we say array simply means a group of items. Think of array as a list of items. For instance, if you want to go to the market to buy, let's say, food stock or food items rather. If you want to buy rice, want to buy beans, want to buy meat, and so on and so forth. You write down a list, isn't it? Number one, meat. Number two, alubosa. Number three, pepper, and so on and so forth. So the same way we have what array in programming in Solidity to be precise. Now the difference between this one here, this array here, and your normal list, the normal list you use when going to the market is that a list can have any type of item. The same list can contain rice. The same list can contain beans, can contain different types of items of any kind, can be part of the list. But then one of the difference with this one is that if you're having a list here, let's say int 32. So let's start by declaring an array first. So to declare an array, you type in everything like this. The same way we have been doing it. Let's say list of, let me use my camera casing. List of number like this. So to declare an array, you just come here after your data type, after this int 32 here, you put square bracket here, and that's it. That's how you declare an array. So you declare your variable the same way you have been declaring other variables, but then where the data type is, you put what? Square brackets. So this square bracket here shows that this is an array, not just an element. So as I was saying, that there's a difference between this one here and your normal list. Your normal list can contain different things, but then arrays in Rust, sorry, I say Rust, in Solidity rather, can contain items of the same type, items of only the same types. For instance, this one here can only contain I32 numbers. It can't contain anything aside that. Now, another thing is you can set the number of items that you want to have in an array. So if you put, let's say we put 5 here now. What this one here means is that this our array can contain 5 elements. Do you understand? Can contain 5 elements. Now here we are not assigning any value to it, but we can come down here and we do list of number like this. Now to access each, remember I told you that it is a list. Okay, let me visualize it for you. Let me write down how it's going to look like for you. It's going to look like this. Let's say we want to have an array of 1 to 5. It's going to be 1, 2, 3, 3, 4, 5, like this. So this one here is array of 5 numbers, 1 to 5. Do you understand? Now, to access this first element here, use the list of number 0, like this. Do you understand? So use list of number 0 like this to access this first number. Now, this like this now, you are reading from it. If you now want to assign a value to it, the same way you have been assigning value to variables or values to variables, you can do something like this, equal to, let's say we want to assign 1 to it as we have listed it here. So I can come here and do 1 like this. So like this, I've assigned 1 to this variable. What's wrong? Expected entire focus 1. This number. Why is giving us error? This is how you write comment. It's supposed to work. Why is it not working? List of number. Enum data type. Okay. Let me do something like this. 0, 0, 0, 0, 1, 2, 2, 5. For some reasons, it's not getting assigned. Okay. Let's do list of numbers dot list of numbers dot, let's say, is there add? Okay, let's do push like this. Okay, wait. Let me do this and do 1, 2, 3, 6 like this. Cancel. Memory is not implicitly convertible. 65. I don't know. Wait. 0. Okay, let's do something like this. Let's do this. Instat it should work now. Why is it not working? Is it because of the int 32? For some reasons, this thing is not getting pushed. One like this. Let me try and comply and compile first. Okay, let me do something like this. Let me get the constructor and see if it's going to work inside the constructor. Oh God, it now works. I think it's because I'm trying to assign the value at the top level. Yeah, that is why it's giving me error. So let me format the code. So for this one here now, let's go back to where we were before. Let me put 5 here. If I put 5 here now, like this, I can assign a value to this array here using indexes. So this 0 here is called an index. In Solidity, arrays are in a zero-based index. Zero-based in the sense that you start with 0, you don't start with 1. Are you getting it? So the first element in an array is at index 0. The second element is at index 1. The third one is at index 2, and so on and so forth. Do you understand? So that's it for indexes in arrays when working with Solidity. So here now, I can do list number like this, 1 here, and put, let's say, 2 here. So I can do something like this number, let's say 2, and put 3, and so on and so forth. Let me come here and put 4 here. Now, remember, arrays are what? Index based. That means I have just one more slot to go. If I put 4 here, let me put, let's say, 5 here. Now, if I should come to this place here now and put, let's say, 5, I'll be getting an error. Why am I getting an error? Because I've gone out of bound. Now, the bound, how do I know I've gone out of bound? I'm specifying 5 here. And this 5 here means that this array here should not be more than 5 elements. Here I've inserted the first element, the second element, the third element, up to the fifth element, which is at the index of 4. Now, on inserting another one, which is the sixth element, I'm getting that error or this error. Now, if I should place my cursor on this red line here, I will saying out of bound array access. So you can't access an array out of its index, out of the specified index. Now, one way of doing this is to use dynamic array. So dynamic array simply means you don't specify a size at all. So if I move this 5 here like this, that means it is dynamic. It means that I can put any number of elements inside of the array. Do you understand? Now you may think that, oh, this is how you'll be creating your smart contract, but then we still talk about the best practice of creating smart contracts, because because of you can create an array like this and start creating all your arrays like this. Are you getting it? There are some implications. Are you getting to these kind of things? We'll talk about those things too as we advance or as we progress in the boot camp. Do you understand? So at the end of today, we have been able to talk about enums, structs, and array. I've also introduced to array. Let's compile these smart contracts and see what it's going to give us or what we are going to get. If I compile this, Now, congratulations to us. Now compiled, no more error. Now let's deploy it. Deploy, delete this, deploy. Let me see. And new editor type. Should be payable. Okay, infinite gas. Let me make this one a 6 back and see. Let's deploy it again. Go to deploy and deploy. Now it's now worked. It now works. So if I should come to this place here and I check the list of numbers, so I'm coming. Input is required. Okay. Let me do 6 like this. Oh, out of bound. Let me do 0 and see. So if you check 0, 0 is giving us 1. Let me do, let's say, 4. We should get 5 now. So 4 is 5. So this one here is working. If I do, let's say, 0 now, we should get 1. You're getting 1. If I do, let's say, 2, we should get 3. Now you're getting 3. Do you understand? Now, we still talk about this sign here, this gas here. That's the reason why it was not working before when I first compiled it. If I should move it 6 here now, we are still going to have the same. We are going to have the same error we were having before. If I compile it and I try to run it like this, so you can see we are running into the same error. So why are we running into this error? We talk about this soon. Do you understand? So thank you very much for today's class. Let's call it a day. I'm going to meet next week. Now, before I come back next week, I want you to practice what we have done today on structs. Just create structs for different, think of many use cases and create structs data type for them. The same thing for enum too. Then do the same for array. Do you understand? So just do that, and we see in the next class. So in the next class, we're going to talk more on why this code did not work when I remove the 6 here. Are you getting it? Also, why we were having error when I tried initializing this array at this top level. This is top level code. Any code that you are putting directly inside of this smart contract here is a top level code. But these ones here are not top level. They are inside the constructor. So we talk about this. We explore these things in the next class. So thank you once again for attending the class. We'll see you next week. Bye. Any question? Hello? Okay.
No question from me.
Chinedu, what about you?
No, I
Okay.
perfectly understand.
Okay. Thank you. Meet in the next class. Bye.
Thank you. Bye-bye.